Have you ever considered the role that mathematics, particularly the concept of zero, plays in our everyday lives? Let's take a moment to delve into the intriguing story of zero. Yes, zero, that seemingly unremarkable digit that, in reality, possesses a rich and transformative history. The invention of zero was not a straightforward process, but rather a journey that spanned across cultures and centuries. In the lush rainforests of Central America, the ancient Mayans were among the first to conceive the idea of zero. They needed a symbol to represent the absence of a value, a placeholder to make their complex calendar systems work. So they came up with a shell-like symbol to represent this emptiness, this nothingness. Simultaneously, halfway across the world in the vibrant culture of ancient India, the concept of zero was also taking root. Indian mathematicians, like the renowned Brahmagupta, recognized the potential of zero, not just as a placeholder, but as a number with its own unique properties. They developed rules for mathematical operations involving zero, which paved the way for more complex calculations. The advent of zero was indeed revolutionary. It transformed the way we understand numbers and mathematics. With zero, we could now express large numbers efficiently, perform intricate calculations, and even explore the realms of negative values and fractions. Imagine trying to multiply or divide without a zero in your numerical system. Frustrating, right? But it's not just about calculations. Zero has philosophical implications too. It challenged the human understanding of void and infinity and spurred debates about the nature and existence of nothingness. So, the humble zero, often overlooked, was the birthplace of modern mathematics, a symbol of nothing that meant everything. It's a testament to human ingenuity, a nod to our constant quest for knowledge and understanding. It's the magic of zero, the starting point that leads us to infinity and beyond. Remember, every number, every equation, every mathematical concept you know today owes its existence to this wonderful invention, the unassuming yet extraordinary zero. With zero in place, the foundation was set for the evolution of numbers and arithmetic. As we journey through the realm of mathematics, we encounter the birth of natural numbers, those simple counting numbers that start from 1 and stretch on into infinity. They are the first characters we meet in the grand narrative of numbers, but the story doesn't end there. Integers, those whole numbers both positive and negative, introduce a new layer of complexity. With the inclusion of zero, negative numbers, and their positive counterparts, we can now explore below the surface. The world of integers delves deeper than mere counting, allowing us to represent debt, temperature below zero, and more. Next, we dance with the rational numbers, fractions that represent the division of integers. They fill in the gaps between integers, weaving a more intricate tapestry of numbers. With rational numbers, we can measure quantities that are less than a whole, like a half apple or 3/4 of an hour. But what are numbers without the operations that manipulate them? In comes arithmetic, the elemental dance of numbers. Addition, the first operation, combines numbers while subtraction takes away. Multiplication, a more complex form of addition, repeats a number as many times as another number. Division, the counterpart to multiplication, splits a number into equal parts. These operations, simple as they may seem, laid the groundwork for more advanced mathematical concepts. They are the building blocks from which the towering structures of algebra, calculus, and other branches of mathematics are constructed. In the grand scheme, arithmetic is the tool that allows us to quantify the world around us. It's the language we use to express the rhythms and patterns of the universe. It's the key that unlocked the door to scientific discovery, economic development, and technological innovation. Arithmetic, the manipulation of numbers, became the tool that propelled humanity's understanding of the world. Through it, we've learned to navigate the seas of uncertainty, chart the cosmos, and even predict the future. So let's continue to explore the infinite landscape of numbers, where every discovery is a step closer to unraveling the mysteries of the universe. And numbers and arithmetic paved the way for the next big leap in mathematical thinking, algebra and calculus. First, let's dive into the emergence of algebra. This branch of mathematics, with its roots in ancient Babylon, is all about solving equations and understanding patterns. It's like a puzzle where you're given a set of relationships, and you have to figure out the missing pieces. It's a bit like finding the missing piece of a jigsaw puzzle, except the picture you're trying to complete is an equation. Algebra allows us to solve for unknowns, to find that elusive x or y. And this isn't just a game of numbers. It's a fundamental tool that helps us understand how the world around us works. But the mathematical journey didn't stop at algebra. Enter calculus, the brainchild of two of the greatest minds in history, Sir Isaac Newton and Gottfried Wilhelm Leibniz. Calculus is all about understanding change and motion. It's the mathematical key to deciphering the universe's most intricate dance. The dance of planets around the sun, the flow of rivers, the flight of a bird, even the growth of populations. It gives us the power to predict, to understand the future based on the present. Algebra and calculus together have revolutionized our understanding of the universe. They have allowed us to delve into the mysteries of physics, to predict astronomical events, to engineer magnificent structures, and to model complex systems like weather patterns or stock markets. They've even helped in the development of modern technology, from designing aerodynamics of an airplane to creating algorithms for artificial intelligence. It's fascinating to think how these abstract concepts, born out of the human mind's innate curiosity and desire to understand, have come to shape our world in such profound ways. They've taken us from the simple act of counting on our fingers to sending spacecraft beyond the limits of our solar system. Algebra and calculus, once considered arcane, are now indispensable tools in our quest to understand the universe. From zero, we now venture into the vast, uncharted territory of infinity. A concept so expansive and profound, it has both puzzled and fascinated philosophers and mathematicians for centuries. Let's start with the basics. What is infinity? In simple terms, it's a quantity without bound or end. It's larger than any number you can possibly conceive. Infinity is not a number but a concept, a symbol of limitless possibilities. Now you might be wondering, how is this concept used in mathematics? Well, it plays a crucial role in many areas, from calculus to set theory. In calculus, for instance, infinity is used to describe quantities that grow without bound, or sizes that are immeasurably large. It helps us understand concepts like continuity, limits, and infinite series. In set theory, infinity helps us grasp the concept of an infinite set, a collection of elements that has no end. This leads us to one of the most intriguing aspects of infinity, the idea of different sizes of infinity. Yes, you heard that right. Not all infinities are created equal. There are actually infinitely many infinities, each larger than the last. But with infinity come paradoxes and mysteries. Take the famous paradox of Achilles and the tortoise, where despite having a head start, the tortoise always remains ahead of Achilles. Or consider the paradox of Hilbert's Hotel, a hypothetical hotel with infinitely many rooms, yet always has room for one more guest. These paradoxes challenge our understanding of infinity, pushing us to question and explore deeper. Infinity, then, is not just a mathematical tool. It's a concept that transcends mathematics, reaching into philosophy, physics, and even the realm of the abstract. It's a symbol of the limitless, the unbounded, the eternal. Infinity, a concept as vast as the universe itself, continues to perplex and fascinate mathematicians. It's a journey into the unknown, a voyage into the infinite, a quest without end. And that's the beauty and mystery of infinity. Our journey from zero to infinity illustrates the power and beauty of mathematics. The story we've been weaving together is a testament to human ingenuity, curiosity, and our unquenchable thirst for knowledge. From the invention of zero, we embarked on this journey, not knowing where the road would lead us. We discovered that zero, a simple concept representing nothingness, would revolutionize our understanding of numbers and arithmetic. The concept of zero, a cornerstone of modern mathematics, allowed us to perform complex calculations and paved the way for the development of algebra and calculus. Algebra and calculus, these two pillars of mathematics, have given us the tools to explore the universe in ways our ancestors could only dream of. These mathematical concepts have become the language of science, engineering, and technology, allowing us to explore everything from the smallest particles to the vast cosmos. Then we reach the concept of infinity, a concept so vast and so profound that it transcends our everyday understanding. Infinity is not just a number, but a symbol of the unbounded nature of the universe. It's a concept that challenges our perceptions and forces us to rethink our understanding of the world. From zero to infinity, we see the evolution of mathematics as a reflection of our own journey as a species. Through mathematics, we've developed the tools to explore, understand, and shape the world around us. From the fundamental principles of arithmetic to the abstract concepts of infinity, every step of this journey has expanded our horizons and pushed the boundaries of our understanding. As we move forward, the story of mathematics will continue to evolve, driven by our insatiable curiosity and our unending quest for knowledge. This journey, from zero to infinity, is far from over. In fact, it's only just begun. The story of mathematics is a testament to human curiosity and our relentless pursuit of knowledge. From zero to infinity, mathematics continues to shape our understanding of the universe.